Alright. Let's continue. Let me check the table of content first. Okay. We are already in chapter 5 and currently in the homework code section here. Let me open that. Okay. I already done this. Oh, right. Wait, let me. Okay. It looks like I found out why there is. What is it called? There is 3 process, I guess. Okay, let me check. So when we set this option with GTP, okay, that is interesting. Safecon must be okay. Anyway, something like this, right? And then we run, let's say, H1. Cannot forget. S1 is, well, it doesn't really matter, I guess. Okay, so when we run the program or the executable, okay, here, let me put this at the top. Okay, so we actually only finished the child process, but not the parent process. So when we run again, the parent process is still there. The previous parent process is still there. So we need to change the inferior like this, continue, and then change again, continue. Okay, now when we check, there's only 1, right? And it is, well, null. The description is null. And now when we run again, inferior, the connection become 2. It is interesting. Wait, hold on a minute. Okay. Even though previously it is only 1, I am still have no idea what's going on. Like, why is this increasing? Inferior 1, continue. Okay, inferior null again. Then if we run again, the connection become 3. So yeah, I'm not sure if this is happen with, what is it called? With program without fork 2. Let me check. What is it called? IIT. Okay. And then right. Set follow for mode child. Test on for off. Okay. Let's say run. Okay. And then maybe let's hit a breakpoint. Eval, something like this. Run again. For inferior. Oh, okay. It also increasing as we run the program multiple times. Interesting. Okay. Inferior. Okay. If we run again, right? Yeah, the connection increase again. Okay. At least now I know that it will be increased as we run the program multiple times. I'm still not sure what information we gain from that. I mean, what the connection even means. Okay. Maybe we will find out later on. We will see. Anyway, we already take a look at this. Right? It's to here. Okay. Looks like there's a difference between opening the file before fork and after fork. Okay. The homework is that open the file first and then call fork. Okay. Can put the child and parent access the file descriptor written by open? The answer is yes. And the behavior is like appending. Okay, let me check that. Okay, right, something like this. Instance.txt. Okay. Let me add the information there. Oh, I haven't started the timer yet. Okay. When we open the file before fork, it looks like the behavior is, what is it called? It's like appending the parent and child output, or combining, I guess. Combining parent and, okay, and type output. But if we open the file after fork, it looks like behavior is write the last output to the file. It's like writing the parent and child, maybe combining. Okay, the behavior is like combining the parent and child output and write that in the file. Okay. But if we open the file after fork, it looks like the behavior is read the last output to the file? Question mark. Open the file after fork. Whether parent or only parent or child output. Alright. And the interesting one, unit character. Okay, previously we kind of get empty line when we are using when we add this printf. Yes, I'm not sure why that happened. And then yeah, I might want to try the write system call instead of the printf, I guess. Let's try that out. Okay. File descriptor count. Oh, the buffer. Okay. Count. Let me try. But then, wait a minute. If I use write, I don't think I can. What is it called? I can add the the format, right? Like getting the PID. putting the PID in the message, something like this. But well, let's try that out. I think it was something like this. Chat process and then count. How many characters do we have here? Is it like 13 maybe? Maybe let's find out. Start chapter S2. Okay, and then let's run that again. Oh, interesting. There is no what is it? New line character, I guess. Let me add another character. Now let's try this scenario. Open file after fork, not using wait, and the new line character in printf like this. But we are using write instead of the printf. Let's see how it goes. Okay, not wait. Okay, alright, let's compile again. Let's do okay. Canvas and then type. There is still empty line. Interesting. Again, in case anyone didn't know, I guess the expected result should be, or at least my expected result should be something like this. There is no empty line in the file. So why is adding adding new line character here, making the content of the file have empty line like this? What's going on? Excuse me. So it doesn't really. Okay. Can we like debug that? checking the state of the file. When we try to read that, I mean, if we have wait in here, right? So we wait until the child process finish. So we wait until the child process finish. Okay, let me demo that. Okay, something like this. There is no empty line. Unlike when we are not using wait. I guess I can do something like this to make it easier to check. See, there's a new line here. But when we wait, what is it called? There is no new line in the file. And if we check, right, there is actually new line in there. And it only happen when we put a new line character in the printf. So what happened there? Okay. Wait. Oh, right. I haven't run this. Okay. Then get. Oh, interesting. Wait. Let me think. Why are we printing two now? Is there something that I miss? Let me check. Interesting. Wait. Oh. Okay, because we are not waiting for the child. There is no guarantee whether we get this or this one. Whether we finish the child first or the parent first. See? Because we are not waiting for the child process to finish, it can be something like this, like the parent first and then the child first. The parent first and then the child later, or the child first and then the parent. Okay, that's quite interesting. Hello, welcome in. So, master the fog with exact pattern. This is the bread and butter of the chapter. Yes, that's what I'm trying to do. And currently we are in the homework code section here. And I'm kind of curious, like why there is a empty line or new line in the file. But when we have this pattern, like the parent, what is it called? The parent finish first and then the child later on. I'm assuming this is what it means, because we are not waiting the child process to finish, right? So there is no guarantee which one will finish first. And when we finish the parent process first and then the child process, it become like this. There is no empty line in the file compared to this one. When we finish the child process first and then the parent process, and if I understand correctly, it is related to this one, the new line character in printf. I am not sure why that is the case. Oh, maybe not, I guess. Oh, sorry. I forgot to recompile. Okay. Parent first and then child and then see. If we finish parent first and then the child, and in the printf there is no new line character, something like this, right? There is no new line character in the printf. When we print the parent PID, there is no new line character or empty line in the file. But if we put the new line character, it suddenly become, there's suddenly a new line, an empty line in the file. And that's kind of confusing. How this printf have anything to do with writing to the file descriptor? I mean, if we print the file descriptor, it should not be the file descriptor 1. I'm assuming. Okay. See, it is file descriptor 3, not 1. So what is going on? Yeah, let me check. See, programming. Why adding new line in print f effective print f, I guess. I mean, the interesting part, if we wait the child process, let me compile this. Okay, we wait for the child process. There is no new line character in the file, or sorry, not new line character, the empty line in the file. That is interesting. Is that expected? Am I lagging? Okay, let's see proclaiming why element character in printf affecting the printf. Oh, Stack Overflow changed their logo or favicon. Interesting. Adding new line character to printf change code behavior. Code below. Prints null. Oh, yeah, I mean, again, if I understand correctly, this is related to the, what is it, the optimization, right? When we add the new line character, it will use print, what is it? Print instruction, is that the word? But when we use this one, but we, what is it? Exclude the new line character, it will, oh, is it the opposite? I kind of forgot, but I remember it is related to the optimization with GCC. So if it is null and there is no, what is it, no new line character, and the pointer is null, GCC will use write to write this null character or content. But if there is null line character, GCC will not handle that and just use the pointer as is, if I remember correctly. Undefined behavior is undefined. Okay. Yeah, I mean, it is, what is it called, related to GCC, which might not be the case with other compiler. To keep that in mind. Okay, I think that it is indeed undefined behavior to pass null pointer. Okay, specifier. That's actually true, but why then it print null? In the other case, if there is no such string to pass to print f, I think this might be an actual bug somewhere. Because the Chinook guy was creative. It refers to much time, whatever. Okay. You would expect to print null in the second case too, because okay, and indeed there is no way that null would be the behavior of the undefined behavior of the given case. I mean, the Chinook guys can do whatever they want, you know. It is undefined. That's why implementation define is scary. Or undefined behavior. Scary. I extended my comment. Put our undefined behavior, so an answer could stop right there. An extension of in glibc, the GNOC library passing 0 for case string in printf considered undefined in the C standard and therefore could very well result in a crash. The developer of glibc decided to do something meaningful instead. The reason the second crash nevertheless is that with the new line, the compiler decided to optimize, right? GCC decided to optimize. Instead of using printf instruction, it used put. Oh, right. Okay. Yeah, it used puts instruction. And then, well, put cannot print out null character. Okay. So without the new line character, we will be using printf. Is that it? I think I have an example somewhere. Let me check. String null with new line. This one. String null with new line. Right. And then, well, I think, how do I generate the assembly file again? I kind of forgot. GCC some assembly file. Is it done? Okay. Generate assembly file. Okay. Can I compile to assembly? that s dot s. Let me check. Not the output. Oh, maybe this S, uppercase S. Okay. This is playground printf string null with new line. Okay. Let me check. This is the, what is it called? The assembly instruction. Is that the term? Okay. I think it is this one, the printf. Right? At PLT. Okay. And then if we, let me put this in here. If we change that to no new line, if we change this to this one, I think if we use multiple format specifier like this, it will still have printf instruction. But let's find out. Printf C1, and then let me copy this. Okay, I think this one, if I understand correctly, it is still printf. Okay. Now let's check this one. Wait. Oh, okay, interesting. Wait, is it related to this? Let me try again. Yeah, it is still printf. Okay. Oh, I had to put the comment to generate the assembly file. Interesting. Oh, right. It should be something like this. Okay. I think this one. Right. Okay. This is one of the optimization in GCC using puts, right? Instead of printf. But yeah, if we let's say use multiple format specifier like this. And if we take, okay, there is no change, right? Like this, it will use printf instead. So the optimization is only when we have this exact format. I assume. I mean, we can try, I guess. Let's add space before the new line character. Oh, what is it? Printf, okay. Something like this. Let's compile that again. Alright, this one. See? If it is not exactly like this, a string format specifier with the new line, it will not using put. Okay. Is that why we got the, what is it called? Is that why we got the new line character? Because of the optimization? I am not really sure. Wait. Alright. I'm not sure if I want to commit this. Yeah. Anyway, let's continue. Okay, I don't think this is what I want to check. Should I like generating the assembly file? Okay. Let's do, and then well, let's try that out, I guess. Where is it? Okay, thing like this. Okay, let's check out the assembly file. Okay, this is the string literal storage, I guess. I am still not sure about assembly. I have no experience reading the assembly. But well, let's take a look. And maybe we can gain some insight. Printf, okay. P error. this is the printf. This is the printf. I'm assuming it is the instruction, the assembly instruction for this. You know, like printf, plt, and then get pid, right? It is this one. I'm assuming it might be incorrect. Okay, interesting. And using printf. Okay. You know what? Let me. What is it called? Str.s. Something like this. And then. But yeah. Wait. Let me add the weight. Okay. Oh, not that one. Okay, s2.s. Let's compare that with this one. Window div this. Oh, okay. Wait, PIT fail. Oh, okay. Yeah, we add this string literal, right? Okay. Alright. Okay. Oh, there is new section in here. Right. Yeah, unfortunately, I still have no idea. Okay, let's put this information down. Okay. If we not using weight, not weight, that process to finish. And new line character in printf. Like below. Okay, not this one. Maybe something like this. There's an interesting scenario where the file content in the file have new fmt line after the chat process content. Here is how to reproduce that scenario. Okay. Open file after fork. Not using read. Okay. The parent process must finish first. And then must finish or maybe must execute that before the chat process. Must be executed before the chat process. Wait, PIT. The typo. Yeah, let's using wait instead. Can we like check how to debug write file? No. Writing to file. Debug when into a file, maybe something like this. Not really debug. Oh, what is it? Not really write the debug message to a file, but debugging the writing process to a file itself. Let me try another. C programming process writing to a file, maybe something like that. Okay. C programming writing message to a file process. Okay. Let me try another search engine. It's the same, huh? Okay. What is the right keyword? printf maybe? Okay, I want to know what's going on in the printf. Okay, let me add information again. Why that happen? Okay, maybe let's continue first. What happened when they are waiting to the file concurrently? That is at the same time. I mean, at the same time, huh? So does that mean not using wait or if it is not using wait, at the same time, huh? You know what, maybe we need a new file. To check that out. Maybe again, I don't think we already talked about concurrency. What is it? We talked about concurrency briefly, but we haven't gotten into the material, right? I mean, it is the second piece from the three piece. So I'm just assuming there is no, there is no separation between the chat process and the parent process. Like this one, else if this condition. If in this condition we are doing something in the chat process, and if in this condition we are doing something in the parent process. So I'm assuming that is what the concurrency in this question is about. Maybe. Hello. What's up, dog? Welcome. We're currently reading this book, Operating System 3 Easy Pieces. Let me copy this in the chat. Or you can take a look at the video description. I put the resource there. And currently we are in the chapter 5 and in the section homework code. And I'm trying to answer this homework question, the second homework question. The first question is, can both the child and parent access the file descriptor returned by open? It looks like we can do that, at least from my experiment. Again, I'm not sure if that is correct or not. I'm just making a hypothesis currently. And then I'm trying to check the second question. What happened when they are writing to the file concurrently? So I'm trying to understand how we reproduce writing to the file concurrently, or at the same time, right? I'm trying to figure that out. Let's zero, okay. How to, what is it? How to write a file, how to write to a file concurrently, something like this. Okay, let's check. Consider a case where multiple processes open the same file and append to it. Checking to the end of a file and then beginning to write operation is atomic. Multiple process can append to the same file and no process will overwrite. And neither process write as far as its write size is. Okay, let me check. Using malloc. Okay, interesting. And what if buff? Oh, okay. Go to finalize. Okay, return status. I mean, why did you use GoTo if it is just free? I'm not sure why. Okay. I don't think this is what I want to check. Okay. Save that safety. Yeah, I need to know how to. Oh, maybe this one. Concurrently using multiple threads in programming. Okay. Wait, isn't this Python? Why? I'm looking for C programming language, not the Python one. Okay. Example of concurrency handling. There are no more results. Okay. Alright. Yeah. To write concurrent in the file. Here be writing a lot of data. Okay, let me try my approach first. Okay, first of all, let's add this, and then if RC less than 0, printf stdl fork file return 1. Okay, and then concurrently, if that is the case, maybe we can do something like this. Sorry, PID, the last PID there is, I'm assuming something like that. Get PID. Okay. But is it really concurrency? I mean, again, I think it also depends on the open, right? On the mode. Like that there is a pen, I think. The file is opened in a pen mode. Before it's write, the file offset is positioned at the end of the file. Oh. Maybe it is something like this. Well, let's find out, I guess. Like this. Oh, wait a minute. Oh, yeah, well, I think it's fine. Okay, is it really concurrency? I am not really sure. This is C++. Okay. On multiple file. I want to do the opposite, I want to read multiple output to one file. Right? Maybe something like that. At the same time, multiple line. Yeah, I'm still not sure what writing to the file concurrently. I mean, how to reproduce writing to a file concurrently. I mean, is it like we just didn't use wait? Can we call that concurrency? I'm not sure. Okay, if that is the case, then we can check something like this, I guess. Okay. It is still put the parent and child is still written to the file, I guess. When writing to the file concurrently. What's the code? Is this the code? But it is only P1, P2, P3, P4. There is no homework code. Wait, let me check. Is it in here? I don't think so. Right. Wait. Let me check. Okay. API generator. Maybe we can generate the concurrency code with here, with this Python script. But yeah, I need to understand, is it really concurrent? But wait. Wait. Okay. I don't think it have anything about concurrency. Okay, I'm still not sure how to reproduce writing to the file at the same time from parent process and the child process. If what concurrency in this context mean we are not using wait, we are not waiting for the, what is it called? Not waiting for the chat process to finish first, right? Basically, there is no specific order or something like that. If that is what the concurrency in this context mean, then well, the answer is that it is still printing out the still waiting. Wait, I kind of forgot. Let me compare again. Not that one. That one, and then okay, that is to okay. It is still writing the parent and the child output to the same file. Assuming we open the file first before we fork. Again, if if we fork the process first and then open the file later on, it might behave different. Okay, let me demo that again. Something like this, right? We fork the process first and then we open the file after the fork. Alright, running that. See, it's like we only what is it called? We only write the last output, in this case only the parent output. Oh, because we are waiting, right? But yeah, if we didn't use wait, then it could be the child or the parent. There is no guarantee which one will be in the file if there is no wait, and we open the file after the fork. That is an interesting scenario. Okay, maybe let's continue first. Write another program using fork. The set process should print hello. The parent process should print goodbye. You should try to ensure that the child process always print first. Can you do this without calling wait in the parent? Oh, interesting. So we are not using the wait system call. I'm assuming we also cannot use the wait PID too. So we cannot use this. There is a constraint here. Cannot use wait and wait PID. Okay, interesting. I think we will continue this on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.